Good day. My name is Michał Kułakowski. I work as a solutions architect for GitLab. Today, I'd like to tell you why and how would you want to integrate HashiCorp Vault with GitLab. Let's start with understanding what HashiCorp Vault is from engineering perspective. Well, functionally, it is a credential database. It implements similar principle to the hardware security modules once used in the industry, except it does it in software. So you have a storage containing the database, and this storage can only be booted into the actual service by using N out of M keys available. And once it is up and running, it can be used to read, write, update, and delete secrets. As simple as that. Interaction happens using API, either directly or via GUI or the command line client. This command line client is the same statically linked binary written in Go, which is used to boot a server. So as usual with Go binaries, it can run practically anywhere. And whenever you want to access the service, you need to talk to one of the authentication services first in order to obtain a token, which will then authorize all the requests to the service. Now, where Vault really gets useful is infrastructure-specific backends. And they are modules implementing this functionality for various types of infrastructure, which can be used interchangeably. For example, for AWS, you can have a backend which defines credential, but this credential is not a static one. It's a dynamically generated credential bound to specific AWS role. So every time you request it, you get a different physical credential, and Vault manages it, meaning the credential has a limited time to live. It can be renewed or not. It can be destroyed once it is not being used anymore, which limits the time of life of this credential and limits the risk of the actual leak of it. Now, from our perspective, what matters from the perspective of integration is that Vault database is built as a tree-like structure. So you have a configuration tree and credentials live in the branches. And the way you manage access to that database is via policies, which grant specific operations on specific branches. For example, ability to write to that credential, or ability to read that credential, or ability to destroy that credential. Now, policies are gathered into roles, which are essentially a group of policies. And every single authentication request to authentication services to generate token happens in context of a given role. So token impersonates the role, and then every request using this token is effectively authorized by Vault to either conduct or not the operations requested. From the perspective of GitLab, the objective is, of course, to make those Vault managed credentials available to the runner so that you can have environment-specific credentials stored in the database. They're not managed within GitLab, but GitLab can still request them and use them as needed. The whole authentication concept is based on JSON Web Token, which is one of the authentication mechanisms implemented by Vault and is used on the GitLab end. JSON Web Token is essentially a JSON document specifying who the GitLab instance is, who the user is, who on behalf of which the execution happens, and the job details requesting that specific access. It is signed by GitLab and it's verified by Vault in process. Authorization, in turn, happens on the Vault role entirely. So by sending the request, GitLab requests a specific role from Vault, and the token in context of this role is either granted or not, based on a match between the JSON Web Token describing the job and the limitations which are set in the role. These are defined by so-called bound claims and are pretty important because they can limit the scope of that integration to particular project or even particular branch within that project. We're going to see that in practice pretty soon. Important part to understand is that those secrets need to be explicitly defined in GitLab CI YAML. So a runner will not extract every possible secret which is available to the role. It will only extract the secrets which are explicitly requested and declared in the GitLab CI YAML. So when you look at the flow graphically, once again, it is GitLab, which is generating JWT, sending it to the runner. Runner forwards that JWT to Vault, which then verifies that with GitLab to make sure that the signature is valid. If it is, Vault would return the token which was previously requested by a runner based on the definition. And if you look at the example JWT, you would see that it contains basically a personality of the job. Which user is requesting, which pipeline ID, job ID, also which project, which specific project is doing this, what is the job name, what is the branch in which this job is running in context. Let's see how this works in practice. I have set up a sample project which would be accessing credentials in Vault. This project has two environments, staging and production. Credentials are stored in environment-specific branches protected by environment-specific policies. And we will protect the production credentials from hijacking from any other environment using bound claims. So let's review first, what do we have defined in Vault? There are two credentials. Production contains username and password, which is production specific. And staging secret contains the same type of credentials, but the password is obviously different here. We do have two policies which are symmetrical. One is relating to the production environment. The other is related to staging environment. As you might remember, policies are essentially granting certain set of operations for a certain endpoint or branch. So here we're talking about the secret sample project staging, and we're granting capability to read and list. And then we do have two roles. Those roles are production and staging specific, and they would be different because they contain a specific bound claims. So when you look at the staging role, important parameter here is this bound claim. It says that this role can be assumed only in context of a specific project ID. So other GitLab project would not get access to that particular role and the policy granted to it. It is then essentially granting a sample project staging policy. When you look at the production policy, it contains even tighter control. Because it insists not only on having this particular project defined, but also it can only be executed if the branch in context of which the job is being run is a master. So now let's switch back to our system. I have a very simple project which only contains a GitLab CI YAML file. And this GitLab YAML is containing two jobs which are meant to retrieve the secrets with the Vault method and then expose them to the console by echoing them to the output. Now, as you can see, those jobs are running on every branch except master for the staging job. And for the production job, we only run this one on master. The way those jobs are being assigned roles is defined by variables. And when you expand this section, you can see that there is a Vault authentication role variable, which is defined separately for production and staging with the relevant values. That is configuring the job to actually request the right role policy and then eventually retrieve the right credentials. And when you look at CI/CD runs, you can see that there is a feature branch pass, which is actually showing the staging specific credentials here. And for production branch, it would list the production specific certificate, production specific password. So now let's assume a user is malicious and would like to hijack production certificate. We know that in GitLab you cannot make changes in master branch without proper merge request. But let's assume our user wants to do that experimentation on a feature branch where he's allowed or she's allowed to do anything they want. So going to feature branch, I have two jobs. And what I'm going to do is within that feature branch, I will remove the limitation on the production job to only run on master branch. I'm expecting now both of the jobs to be running on my next CI run. Again, I can only commit them to feature branch without additional permission. This is what I do. And I can see that the pipeline has failed already. Let's see why. This pipeline contains both jobs. This is expected. It contains a successful staging job. This is expected because we're in staging environment. But the production job failed. Let's see why. The reason it is failing is that Vault is giving us 400 code. It is validating claims, and it sees that the claim on the master branch is not satisfied. So this role cannot be granted, which is our way to fence production credentials and defend them against malicious use. With this integration, you can use Vault to store your environment-specific credentials externally to GitLab, manage them with HashiCorp Vault, and yet use them in the job as you need them on the go. Thank you very much.